All right, so good evening again. We're doing statistics, and right now we are looking at we're continuing to look at on-group data. We're continuing to look at on-group data. All right, so example 4 says a 6-sided die was thrown 30 times. The table below shows the number of times each score was obtained. So this is on group data. A die, Jamaicans would normally pluralize this word and we normally say dice, but it's actually a die, singular die, plural dice. So a 6-sided die was thrown 30 times. Now, if you throw a die 30 times, you're going to get 30. You're going to get 30 scores. Let's call them scores. So normally, when you throw a die, you record the number that is on top when the die stop moving. All right, so this die was thrown 30 times, and this table records the number of time each number was on top. So 1 was on top only once, 2 was on top 3 times, 3 was on top 6 times, 4 was on top 9 times, 5 was on top 7 times, and 6 was on top 4 times, and this is a total of 9 times. A total of 30 times. Guys, I will remind you that n, which is the number of values, is equal to the sum of the frequency. N, which is the number of values, is equal to the sum of the frequency. All right, this says, the first question we're asked is, what is the probability of obtaining an odd number score? All right, so the first thing we want to know is how many times altogether there was an odd number score. All right, so these are your odd number scores, 1, 3, and 5. And 1 was there, so the number of odd number scores, the total number would be 1 plus 6 plus 7. There was 1 1, 6 3s, and 7 5s. So there was a total of 14 odd numbers. So from this 30 times of rolling the die, an odd number came on top 14 times. So the probability of getting an odd number would be equal to the number of odd numbers, which is 14, over the total number of times the die was rolled, which is 30. So the probability is 14 over 30. And of course, your probability can be written as a fraction. It can also be written as a decimal. So 14 divided by 30 is 0.47. So this is equal to 0.47 or 47%. So what is the probability of obtaining an odd number score? The probability from obtaining an odd number score from rolling the die 30 times is 47%. The next thing we're asked to identify is the median. The next thing we're asked to identify is the median score. Guys, the median is the middle value when the values are arranged in ascending order. So let me give you an appreciation. This is not answering the question, but I want to give you an appreciation of what the scores look like. There's only 1, 1, 1. Only 1 time 1 was on top when the die was rolled 30 times. There were 3 2s. There were 6 3s. There were 9 fours. You get the picture, right? So this is what my data looks like. All right. Now the median would be the middle value when the values are arranged in ascending order. Obviously, I'm not going to sit down and write out the 30 values. And even if I decided to do that in this case, what happens when there are 1,000 values? Obviously, we're not going to sit down and write out the 1,000 values. So it means that there must be some other way for us to identify which score is the median score without having to list all of the values. All right. So let me show you how to do that. I did already, but I'm quite sure persons won't remember. And these things, guys, require practicing. So if you're dealing with ungroup data and you're asked for the median, you need to put in the cumulative frequency. Cumulative, let me write that a little higher. Cumulative frequency. Now, cumulative frequency is adding the frequency as it goes down. So let's add the frequency. The first one is 1, then 1 plus 3. This is 4. So cumulative frequency is like a running total of the frequency. Then we have 4 plus 6, which is 10. 10 plus 9, which is 19. 19 plus 7, which is 26, and 26 plus 4, which is 30. That's the cumulative frequency. So we need the cumulative frequency. Another thing we need to do a calculation to tell us which number, which value in the distribution is the median. So we're going to do this. So the median, so I'm making a note. This is a note, something that you should know. The median, and the symbol for median is Q2, is the n plus 1 over 2 th value in the distribution. All right, I'm gonna write that. So QH is the Q2, which is the median, is the n plus 1 th value. The th there is telling you what is the position of the median. So let's perform this calculation. First of all, n is 30. So n plus 1 over 2 is the same as saying 30 plus 1 over 2. This is 31 over 2. This is 15.5 th. So what this is saying to me is that the median is the average of the 15th and the 16th value. That's what this is saying to me. The median Q2 is the average of the 15th and the 16th value. The 15.5 is telling me that the median is between the 15th and the 16th value. Everybody should also remember, whenever there's an even number of values, the median is the average of the two middle values. Guys, there are 30 values, so the median is the average of the 15th and the 16th value. That is what this calculation is saying. All right, guys, so let's have a look now at how we're going to identify which value is the 15th value and which value is the 16th value. Need your undivided attention. Guys, the first value is 1. The first score is 1. Now, the second to the fourth score is 2. The fifth So the 10th score is 3. Remember now, I want the 15th and the 16th because the median is the average of the 15th and the 16th values. So after 10th, there's the 11th. The 11th to the 19th value is 4. Guys, if the 11th to the 19th value is 4, it means also that the 15th and the 16th value is also 4. If the 11th to the 19th value is 4, and I need the 16th and the 15th, it means that the 16th and the 15th value is also 4. Therefore, guys, Q2, the median, is equal to 4 plus 4 over 2 is equal to 8 over 2. The median is equal to 4. The median, guys, is equal to 4. Please remember how to determine the median when you're dealing with ungroup data. How to determine, this is how you determine the median when you're dealing with ungroup data. Next, guys, the next thing we're asked to do is to show that the mean score is 4. Mean is another word for average. Now, guys, whenever you're asked to find mean and you're dealing with ungroup data, frequency table, ungroup data, you need to put in a column called FX. Now, FX stands for frequency times value, or in this case, score. The frequency is 1, the score is 1, so this is 1. This is 3 times 2 times 2. This is 6. This is 6 times 3, 18. 9 times 4, and this is 36. 7 times 5, 35, and 4 times 6, this is 24. 4 times 6, this is 24. What I need is the sum of fx. Now, the sum of fx, let's add this up. All right, this is 59 and 160. This is 95. 95 plus 25 plus 120. This is equal to 120. The sum of fx is 120. Guys, the mean x bar is equal to the sum of fx divided by n. So the mean is equal to 120 divided by n, which is 30. Guys, the mean is 4. We were asked to show that the mean is 4, and we just did. We were asked to show that the mean is 4, and we just did. I'm turning the page in a second. Next, this says, the die was thrown a further 5 times. So initially, the die was thrown 30 times, and the sum of the scores, guys, the sum of fx represents the sum of the scores. The sum of fx represents the sum of the scores. The sum of the scores from the first 30 through is 120. Remember, the way to get average, it would be to add up all of the scores and then divide it by the number of scores. When we added up all of the scores, we got what? 30. So when they throw the die the first 30 times, the scores added up to 120. Guys, we're now told that the die was thrown a further 5 times. So now it gone 35. What is the sum of the scores obtained if the mean remain the same? Now, the mean, guys, the mean x bar, that's a symbol, is the sum of fx divided by n. Now, the sum of fx, this is the sum of all values. Or in other words, that's the sum of the scores. Now, the die was thrown a further what? 5 times. Tell me if you agree. N is now equal to 35. It was thrown initially 30 times. It was thrown an additional 5 times. So now the die has been thrown in total, a total of what? 35 times. We do not know the scores for the 5 additional throw, but what we know is that the mean remains the same. So if we put in everything, the sum we don't know, the sum of fx, the sum of the values we don't know. We know that n is what? 35, because the die has been thrown a further 5 times, and the mean remains the same, so the mean is still 4. Guys, if I have 1 fraction is equal to 1 fraction, what do I do?
Cross multiply.
Let's cross multiply. Then 1 times the sum of fx is the sum of fx is equal to 35 times 5, which is 140. So guys, what this is saying is that the die was thrown an additional what? 5 times. The mean remains the same because the sum of the 35 throws is 140. That is what it is saying. Let me ask you guys, before the additional 5 throws, the sum was 120. After the additional 5 throws, the sum is now 140. What would be the sum of the 5 additional throws? Anybody? One more time. The first 30 throws, the sum of the score was 120. The die was thrown an additional 5 times. And now the die was thrown an additional 5 times. And now the sum is 140. Here's what I'm asking. What I'm asking is this. What is the sum of the 5 additional throws? Anybody?
What?
The sum of the 5 additional throws, what is it?
20.
Say that again.
20.
All right, 20. Very good. Here it is. If no score was repeated more than once, list at least one possible result of the 5 additional score. So what we need is 5 scores that add up to what? 20. I have 1, 2, 3, 4, 5, 6. If I take this one out of it, these 4, there are these 5 add up to 20. 2 plus 3 is 5. 5 plus 5 is 10. 4 plus 6 is 10. These 4 add up to what? 20. So the 5, one possible, list at least one possible result one possible result is 2, 3, 4, 5, and 6. If for the additional throw, the person throw 2, 3, 4, 5, and then a 6, the 5 throws would add up to a total of 20. All right, the last thing in this question.
Sorry, excuse me. Why couldn't one be one of the possible throws? Sorry, I
Yeah,
couldn't
but
hear.
sure,
I wasn't hearing.
but which number would you take out? I remember now, the 5 score must add up to 20. If you
Uh,
put 1, which other numbers would you put in that would add up to 20
Never
along with 1?
mind.
Trust me, these are the only 4 possible numbers you could have. You could change up the order, but it must be these 5 because the 5 of them add up to 20. All right, the last thing we're asked to do. The last thing we're asked to do is that we're asked to draw using a scale of 1 centimeter to represent 1 unit on both axes. We're to draw a frequency polygon to represent the information. Now, guys, for the frequency polygon, on the vertical axis, you're going to have frequency. On the horizontal axis, you're going to have the value. All right, let's plot. If we go back to our tables, or you guys can help me. I think 1, there was only 1, 1. How many times 2 occurred? Anybody? Back to the table. How many 2s?
3.
3. 3 2s and 6 3s. So there were 3 2s. So 2, there were 3 2s, that's here. There were 6 3s, that's here. How many 4s? 7? How many 4s? 9 4s? How many 5s?
7.
And how many 6s?
4.
4. Now, the frequency polygon must be drawn using a ruler. So I'm going to connect my points them using a ruler. So I'm connecting my points using a ruler. All right. Connecting my points using a ruler. Connect them in order. Connect them in order. In order. All right. So guys, these are the values I plotted. 1, 2, 3, 4, 5, 6. Those are the values I plotted. Now, the values are on the horizontal axis. Here's something about the frequency polygon. The frequency polygon must start and end on the horizontal axis. It's going to start 1 before the first value. The first value was 1, so it means that the frequency polygon is going to start at 0. It is going to end 1 after the last value. The last value was 6, so the frequency polygon is going to end at 7 on the horizontal axis. So it starts here at 0 and ends here at 7. So just to do those final connections, and we will have our frequency polygon. final connection, and we will have our frequency polygon. This is what the frequency polygon looks like. On the vertical axis, we have frequency. On the horizontal axis, we have value.